Hello everybody, I am Ben from Team Panic and it's Melty time. We are back onto the Melty brain and hopefully today we're going to get this thing actually doing the meltying and getting it spinning, although probably not quite in this orientation. I have a design already for a safer test chassis that we can use to actually spin up this Melty brain, and I can spin it up safely in my house without having to try and track down a built beta weight arena to actually be able to safely test this thing out. Because the last thing I want to do is lose an eye trying to spin up a Melty brain. That does not sound like a great idea. So the first thing we're actually doing is we're going to change the wheels over. Well, while we tear this down and rebuild it in the safe formation, we're going to change the wheels over, because originally we had my wheels that I put on Annie Are You OK, basically just modified to run on brushless hub motors. These things have a silicon tire around the outside of them, which gives them all of the grip they need, but that is normally just glued in place. Now, at ARC's March meet, my teammate in Team Bolt, Steve, had built his own Melty brain running on OpenMelt. We're going to try and run on some form of modified Halo code today, but we'll get to that in a little bit. He had built his own Melty brain running on OpenMelt stuff. He tried with his wheels first and they came flying off, and then he stuck these wheels on and this happened. So immediately after starting up, the silicon, even though it was glued down, came flying off of these wheels. But then running on these wheels, which are a PLA Flex wheel, it actually melted properly and it translated back towards us on the side of the arena before, of course, the battery came flying out. So these alone, without the silicon, are enough to melty, and that is what I needed to know. So we're going to swap away from the two-part wheels, and we are going to go with just PLA Flex wheels. I've added some extra little flaps to the outside of this to hopefully get just a touch more traction out of them, but we're going to swap over to these, and hopefully moving over to these means that we'll be able to melty properly without losing wheels in the process, because yeah, it turns out that the amount of force that you get when you spin an entire beta weight robot up is quite absurd, and it is very, very capable of throwing batteries, throwing tires off wheels, throwing links out of things. So we're going to have to be very, very careful with this. All right, so let's get into building up the safety version of this so we can start with the melting. Okay, so that is the safety chassis done and dusted. It is locked together for the most part. The wheels are in place, everything is looking good. And like I said, this we should be able to spin up safely without it damaging anything that I have going on around it, because I don't actually have an arena big enough to spin this thing up. So we're gonna have to try and do this as safely as we can without an arena, which is why, yeah, nice little safety cage version of the Melty. So now it's time to look at the heart and soul of this Melty, which is actually just 3 boards. So this guy on this side is an S-bus receiver, which means it can send 16 channels to our brain, which is a Teensy 3.2, which is basically an Arduino that runs really, really fast, which is what we need when we're going to spin the whole thing at really high speed. And then we have a really high G-force accelerometer, which is also what we're going to need. Because even though this thing can do like, it's 250 or 2,500 Gs, like it's a lot of Gs, with the speed that we're spinning, we still had to bring the chassis wall in closer to the center. I wanted the chassis wall to be further back out, but this here, if I mount the accelerometer chip right there, with the wheels at top speed, we are going to just under max out this accelerometer, which is insane. The amount of G-force, or the amount of force on this this thing, and centrifugal force as it spins around, is going to be crazy, which is going to be great. So these are the guys we need to try and link up, and the first step, of course, is going to be getting the S-bus receiver talking to the Teensy 3.2, and then we'll get the accelerometer in, because first I want to do the tank steer mode, because we need a tank steer mode to get out of trouble, basically, and then after that we'll start working on getting the accelerometer in, and when we get that in, that's when we can do the melting. Now, the big issue here is that this guy runs on 5 volts and these guys run on 3.3 volts, which normally is not great. Normally those type of things aren't compatible. However, the Teensy can take more than 3.3 volts in and does have a 3.3 volt power line off of it, so that's cool. We can connect those two together, no problem. And apparently there's a couple of pins on the Teensy which can run on 5 volts or have 5 volt input. So fingers crossed we can get these guys linked. And that's actually where this thing is going to come in. This is a bit of an ugly lump, but this is a Beck board that I did a little while ago that will hopefully help it. So I'm going to get some soldering done. I'll probably get this stuff connected together off camera, and then we'll get some stuff going in here to do the tank steer mode first. And now all of that is together. We've got the Teensy over here, we have the radio S-bus receiver sitting up here, and we have a regulator that takes the voltage from a 3-cell battery down to something that the Teensy can actually handle. And then this stack here lets the Teensy control the lights. So if I just plug this all in and show you what's going on here. So at the moment, I've got a Tyrannus QX7 over here, which is now paired into the S-bus receiver, and if we plug this in, you'll see the lights go blue, which that might be difficult to see on camera. I'm not really sure. And then I can flick a switch over here and put it into a different mode. So we've got green at the moment, and then we've got blue, green, and then we've got blue. So the default mode at the default position is going to be a tank drive mode. Then I've got this intermediate mode, which I'm not really sure if I'm going to do anything with yet. So it might just stay as is for the moment. And then we've got Melty mode, which will be in green. So this, as you can see, is actually working rather well. The only thing is, this should actually also have a red mode when the transmitter is disconnected, which happens now. That should be red. It is not red because I stuffed up the wiring in here somewhere. So while all of this is temporary, and this board was always going to be temporary, I was thinking I was going to fight with this board, but because I don't have the red mode, we're not ever going to fight with this one. I'm going to have to probably do a custom circuit board for all of this mess at some point. And once everything powers up, you can see it goes back to the mode switching that we had before. So next step is actually to get the accelerometer and get the accelerometer plugged into this mess, because this is all very temporary. Once I have the accelerometer working in this temporary stack up, then we will cut all these leads, wire them all together so we don't need this perf board, and get it actually working in the robot. But for now, accelerometer. So it has been ages since that last clip where we got the chip set up, talking to the S-bus and talking to the receiver and all of this stuff, mostly working other than the bug in that. But I've spent a lot of time trying to get this accelerometer to work, and I hate accelerometers. Oh, they're finicky and annoying, and they never quite do what you think they're going to do. It's taken me a very, very long time to get anything even half like a semblance of an understanding of what's going on with this stuff. The accelerometer I can now read, kind of. I went through a whole bunch of different examples and a couple of different libraries specifically for this module I have. None of them were really working the way I wanted them to, so I ended up taking a lot of time and reading through a lot of the Halo code. So the guys from Halo at Bugglebots have put their code up online, and I've spent a long time reading through that and just digesting it and understanding it and trying to work out what the hell it's doing. And using their I2C protocol, I was able to finally get this chip outputting some level of data that's useful. But we're getting stuck. I'm getting bogged down in this. Like I said, it's been a while since we got this thing together. And the Halo guys have done something really smart that I can't do, unfortunately. So, okay, I'm gonna stop myself there. To be perfectly honest, when I recorded that last clip, it was late, and I was a little bit tired and just ranted for like 7 minutes about how much I hate accelerometers, which, to be fair, I still do. But the upshot and takeaway from all of that is that this guy's probably not going to spin up properly this week. Halo have been very, very clever with the way that they've done their meltybrain system, such a way that you basically can't use their code unless you rebuild everything that they've done from scratch, and then also do some empirical testing that they've done. And the accelerometer that I have, I can't get decent G-force values out of it, not G-force values that make sense. Like if I have the accelerometer sitting on the table here, this reads that there is 1 G going down, but if I then, it reads 1 G properly, but then if I flip it over, it doesn't read minus 1 G, which is what it should be doing. And also I'm getting noise in the order of like 4 G left and right and back and front, which is not great. So the accelerometer is going to be an ongoing issue for me. I might, maybe, after we've done this next little test, just try and jam Halo's code in and just see if it actually can pull a heading off of Halo's code. I highly doubt it will, because the radius of my chip is going to be different from the radius of their chip, so there's a good chance it's just not gonna do anything, and it might give us a heading that's like half the robot. Whatever. Anyway, for right now, what I want to do is get the ESCs going, because these are the last piece of the puzzle. I actually don't 100% know right now if this chip with its 3-volt output is going to be able to drive these natively, or if I'm going to need to do what I did with the LEDs and build an extra board with transistors on it to boost the signal up to what the ESCs need. So we're going to get everything in here now, and we're going to have a quick little test to see if we can actually get the motor spinning based on just this chip. So this is a scary time, because we're about to plug this in for the first time ever. And yeah, actually that's probably a bad idea. But we're gonna do this anyway. I did just do a quick little test with this set up and everything seemingly plugged in, and my lights have stopped working entirely now, so I don't really know what's going on with them. I think it's just because I'm using transistors which probably aren't really spec'd for what I'm trying to do with them. They're literally just what I had in the house. So we're gonna give this a whirl, and I'm going to keep my hands near this plug and just make sure that nothing explodes, basically. Actually, we'll also move back a little bit so you can see all of the electronics stack up, just in case there is some nice little smoke out of something, which I really hope there's not at this point. Okay, that's interesting. So, fun fact for all of you, it doesn't actually work that well if you don't use the right code. basically what was wrong. The teensy had the code for the accelerometer testing I've been doing, and not the brand new piece of code that I'd just written to do the test of the ESCs. So that's why that did not work, because yeah, it was running the wrong code entirely. So if we do this, and then plug the battery in, maybe we'll get something going. Wow, okay. Both of those just jammed on, full bore, no problems. What? That's not good. Yeah, there's something up with that. Let's go into test mode and see if we get the same result. Okay, so in test mode, we do not get that massive spin up happening. So that's good, at least. The code is understanding that it's in a different mode. Let's go down into Melty mode. Cool. Melty mode engaged and nothing is happening. Alright, I need to double check my code and just work out what signal was being sent to this thing, because that really should not have just like taken off like that. Also, shit. That has actually, the power wiring is too close to the wall here, and that has actually nibbled at the power wiring. That's really not good. All right, 5 seconds and I will fix this. Okay, so I double checked everything and it was my fault. Well, I mean, obviously it was my fault. I'm the one doing this. But the S-Bus receiver that I'm using doesn't send regular pulses that you would normally send out to a ESC of some kind. And that's basically what went wrong. I just kind of wrote really quick code that when it was in tank drive mode, it was literally just going to take stick 1 and send that to one wheel, and then the other axis on the stick and send it to the other wheel, forgetting that these are at a different range than the signals that go to these. So that's why they turned on and went full bore really quickly, but it did show us one thing which was quite important. It's that the teensy can control these things without having to step the voltage up, which is great, because that means less parts and less components and less complexity and less things to fail. Awesome. All right. Having said all of that, let's actually do the proper test now, and I'm going to throw this into Melty mode to start with, so that I know that I'm in control of these motors. Mid mode, full mode, okay. Yes! Woo! Okay, and now that I've kind of moved things around, everything sits clear, which is great. I do need to cut down some cable ties so that the cable ties don't rub, but that's looking good. So I just now need to throw some pre-made mixing code that I have already into this thing, and we'll be good. We will be golden. So let me do that, and then we'll actually get to drive this thing around. We will not get it melting today because, it's just, yeah. Melting, which, look, a lot of people know, melting is a difficult thing, and accelerometers are really the pain in that. Anyway, I'm going to get this thing actually moving as a platform. I'm going to give this just a quick little shot anyway. So here we are at the end of the video, and things didn't really go to plan, hey, but we can learn from this, and I think that's kind of the biggest takeaway, is that we should always be failing and learning. So this has definitely been a bit of a fail, but what can we learn from this? What have we learned from this? First of all, the Teensy is really cool. It can handle talking to ESCs and also our receiver for our transmitter, all without having to have different voltage regulations, which is great because less parts in the robot means less things that can fail. I like that a lot. It'll also mean that when I do eventually do a circuit board for this, because that is where this is going, the circuit board can be compact and a lot simpler. We don't need to worry about a lot of the stuff I was thinking I was going to have to worry about, which I like. That is really cool. The wheels, these PLA Plus wheels, can rip through wiring insulation if I'm not careful, so I need to be very careful about that. Thankfully, I found that out now and not kind of halfway through a fight, because no, thank you. Accelerometers are interesting. They are different to what I'm expecting. They're different to what most of you, I think, expect an accelerometer to do and to be. So I personally need to sit down now and do more reading and just wrap my head around accelerometers a lot more, or I need to bypass that and go straight into the Halo code stuff and hook up an IR beam and just do exactly what they did. Set the whole thing up with an IR beacon and just run the code that way and just know things based on empirical data, which honestly at this point in time, not sounding like a bad idea. It is definitely a lot easier than trying to map the value that comes out of the accelerometer into something that is usable to then do a lot of maths on to then, you know, get things working. It's a lot easier just to take that raw value and be like, oh, here's an equation, plug it into that, boom, done. So that might be the next step here. I do think I have some IR beacon stuff sitting around, probably not quite to the same level that they had when they did theirs, but I don't know, maybe we can get that stuff working. Yeah, also I need to work on shrinking all of the electronics in here too. You can see that all of this is a bit of a mess. I mean, we are still using the breadboard, so that is always going to shrink anyway, but the XT60s that I'm currently using to power up the ESCs and stuff, that's way too massive. We need to shrink those down, so probably get some XT30s if I can. I'm going to order them today. Who knows when those are going to show up though. Meh. Yeah, all right, anyway, I think that's what we've learned. We've learned a fair bit. I've learned a fair bit through this process. This is not the end of this project. I'm going to keep working on this. I know where I am and where I need to go from here. So probably, like I said, 2 weeks and we'll see another Melty Brain video, possibly. We'll see how some of those upgrades and stuff go. And also we'll see when I go into my storage or into my workshop later and look at the IR stuff I have, we'll see if I can get that IR beacon sensing stuff going. It wasn't something I wanted to do quickly. I wanted to get this thing spinning first, but it looks like the IR beacon stuff might be the first way to go. And in actual fact, we might run this accelerometer less entirely to start with. We will run an IR beacon, interpret the data off the IR beacon, and then just go from there, maybe. Anyway, that is going to be it from me today. I hope you guys have enjoyed this one, despite the fact that it's been a bit all over the place. Anyway, I will see you in the next video.